The James Webb Space Telescope captured something that wasn't supposed to be possible during a routine scan of the Abell 2744 galaxy cluster. What scientists call Pandora's cluster. JWST's infrared camera picked up a structured anomaly buried in the background radiation. Flicker, yes, but not random, not chaotic. This wasn't lensing, this wasn't noise, it was deliberate, a clean symmetrical pattern that repeated across space like a whisper from something intelligent, something beyond us. At first the Webb team tried to explain it away. Maybe it was a sensor glitch, maybe an imaging artifact, but the distortion held through every exposure filter and focus tweak. The anomaly didn't vanish, it stayed anchored in the data like a stubborn truth refusing to be dismissed. The symmetry wasn't just beautiful, it was the natural. NASA made an unprecedented call. They handed the raw light data to Google's quantum computing division, not because they thought it was aliens, but because this wasn't a job for human logic anymore. It was time to let a machine think like the universe. Google's Sycamore quantum computer didn't approach the data like a human would. It processed every possible pattern, simultaneously mapping the seemingly random noise in high-dimensional space. What came back wasn't just a model, it was a message etched in the fabric of light itself, a mathematical imprint that wasn't random. It aligned almost perfectly with the predictions of string theory and higher dimensional frameworks, concepts that until now had existed only on chalkboards and in theoretical physics journals. To be clear, this wasn't proof of aliens, this was bigger. The data matched brain world models, those wild ideas in which our universe floats like a thin membrane within a much larger cosmic structure. In this model, gravity is the only force capable of leaking into other dimensions, which is why it appears so weak compared to everything else Webb might have just photographed. The scar left behind when that leak occurred. Imagine the universe as the skin of a drum and imagine something pressing against it from the other side. Some unimaginable structure brushing up against the surface of our cosmos. That contact leaves a mark. Hand Webb with its unparalleled sensitivity caught it not once but multiple times in different regions of the sky and through different filters. Each time the same structured diffraction signature echoed back. If this interpretation holds, it could explain some of the biggest mysteries in physics. Why is gravity so weak? Why is the universe expanding faster than expected? Maybe dark energy isn't energy at all. Maybe it's pressure from another dimension. Maybe dark matter is a shadow of something real but just out of reach. The implications are staggering. If these anomalies are evidence of gravitational bleeding into higher dimensions, it means our understanding of spacetime is not just incomplete, it's embarrassingly limited. We've been building castles in the sand, unaware that an ocean was swirling just beyond our perception. Research institutions are moving fast. MIT and Caltech are running simulations. CERN is re-evaluating particle collision anomalies. Even DARPA and U.S. military research labs are quietly reviewing what could mean for navigation, for detection, for yes, communication, but not everyone's celebrating, because if we saw something, that means it might have seen us too. We didn't aim for Webb to find intelligent signals, but light travels both ways, and if patterns are reaching us across folded space, then whatever lies beyond could be aware of us now. Maybe has been for longer than we care to imagine. Maybe these distortions are a side effect of observation hours, or there's unease growing behind the scenes. Some worry we've stumbled into a realm we don't understand, that this fingerprint isn't a scientific clue but a warning, a boundary, a veil we weren't meant to pull back. Because remember, the place where this anomaly was first detected is named Pandora's cluster. Scientists laughed at the coincidence. They're not laughing anymore. This wasn't a signal, not in the traditional sense. It was something subtler, more elegant, a dimensional crease that mirrors the structure of theoretical frameworks long Dismissed as fantasy until now. Peer-reviewed papers are hitting journals faster than anyone can keep up. Every week brings new refinements, new confirmations, but here's the part no one wants to say out loud: this might only be the beginning. If Webb has caught these distortions in one part of the sky, it could catch more. It could map the contours of another reality altogether, one interwoven with our own. So the question isn't what did we find, the question is what found us. If Webb, a telescope built to look back in time, has accidentally glimpsed a multidimensional framework, then our place in the cosmos just got a lot smaller and a lot stranger. The camera didn't just capture galaxies, it may have photographed the architecture of reality. For decades we assumed the rules of reality were set, that space curved, light traveled at a limit, and time marched forward in a straight line. But the latest image from the James Webb Space Telescope has cracked that certainty wide open. What its infrared camera caught in the Abell 2744 cluster isn't just hard to explain, it may be impossible under any known framework of physics. This wasn't a black hole or a new galaxy, it was a diffraction pattern. But not just any pattern, one that repeats with eerie precision, embedded deep in the light from galaxies billions of years away, and it doesn't fade with distance, it doesn't distort like gravity. Should it holds symmetrical and stable across regions of the cosmos that should be chaotic. What does that mean? It means light, the very thing we use to map the universe, is doing something it shouldn't. It's moving through space in a way that breaks the rules. Our rules. Some researchers now believe this might be evidence of light skipping across dimensions, not bending, but slipping, gliding through geometries that don't exist in our three-dimensional reality. Think of it like this: you're looking at a shadow on a wall, but the object casting it isn't in your room, it's in another one entirely. That's what Webb may have photographed: shadows of something pressing against the fabric of our reality from the outside, something structured, something intelligent, or at the very least ordered. Because this isn't noise, this isn't randomness, it's a message written in physics itself. Quantum physicists are now suggesting that the patterns align with models of extra dimensions predicted but never observed until now. If this holds, it could explain why gravity is so weak, why dark matter behaves the way it does, why the universe is expanding faster than it should. It would mean the universe we see is only a slice of a much larger whole, one with directions and structures we can't yet describe but can now detect. And this detection didn't come with fireworks, it came quietly, buried in the math. The Webb team didn't shout it from the rooftops, they double-siege checked, recalibrated, ran the numbers again, and when it wouldn't go away, they handed the data over to quantum AI systems to analyze the results. Patterns that match no known cosmological model but mirror predictions from speculative theories long dismissed as fringe. These aren't guesses anymore, they're measurable, they're repeatable, and they're challenging everything from Newton to Einstein. We once believed Earth was the center of everything, then we believed our universe was all there is. Now we're beginning to accept that our entire universe may just be a ripple on a deeper sea. Webb ironically wasn't built to detect this, it was meant to look backward into our past, into the first light after the Big Bang. But by doing its job too well, it may have captured something even deeper, evidence not of what came before us but of what surrounds us, unseen, a higher dimensional framework that doesn't just cradle our universe, it interacts with it, bends it, shapes it. The implications are staggering. If light is using hidden dimensions as shortcuts, then the speed of light isn't a barrier, it's just a limitation of our perspective. Our physics might be a localized dialect in a much larger language of reality. What we've called constants, mass, time, space may simply be regional settings, variables shaped by where and how we're embedded in this larger architecture. And while theorists debate, institutions are already reacting. Particle labs are reanalyzing collisions for missed patterns. Defense agencies are privately asking whether higher Dimensions mean higher threats or opportunities. Universities are scrambling to update everything from physics syllabi, cosmology models, because this isn't just a discovery, it's a reset. We're being asked to consider that our universe isn't a self-contained box but a membrane, a brain floating in a sea of possibilities. Some even wonder if this is the first step toward discovering how to reach across those membranes, not to travel through space but through dimension, through structure, through what may be a cosmic operating system far larger than anything we've imagined. And the truly unnerving part, we didn't even know we were looking. There was no mission to find this, no theory begging for proof, just a telescope methodically capturing the light of ancient galaxies and returning an echo of something bigger, a ripple, a scar, a signature. It's tempting to think we've uncovered something sacred or forbidden, but maybe it's neither. Maybe it's just the next chapter of understanding, one that makes the last 100 red years of science feel like a prologue we sent Webb to capture the light of the first stars. Instead, it may have shown us the scaffolding behind reality.